In the previous video, we discussed the concept of hydrologic frequency and parameters that quantify it, such as AEP, EY, and ARY, and clarified the differences among these commonly misunderstood terms. But understanding the definitions is only half of the story. In practice, engineers frequently need to estimate the probability that a flood will occur at least once during the design life of a structure, or the likelihood that a particular event may occur multiple times within a few decades. In this video, we will go through a few practical examples to see how hydrologic frequency is used in flood probability calculations. Stay with me. In our first example, we want to find the probability that a flood with AEP of 0.02 does not occur during the 50-year design life of an infrastructure. To answer this question, we refer to the definition of annual exceedance probability. In this case, the chance of a flood being equaled or exceeded is 0.02. or 2% each year. So the chance of no exceedance in each year is 1 minus 0.02 or 0.98. Since hydrologic events are statistically independent, we can multiply the calculated probability of each year by the probabilities for every other year. This can be shown like this. Inserting AEP of 0.02 into this equation will give us 0.364 or 36.4%. In our second example, we want to find the probability that a flood with AEP of 0.02 is equaled or exceeded at least once during the 50-year design life of an infrastructure. Referring to our previous example, our desired probability will be calculated like this. P of exceedance at least once will be equal to 1 minus probability of no exceedance. Or in a more general form, it will be like this. So the final answer will be 0.636 or 63.6%. In our third example, we want to find the probability that a flood with AEP of 0.02 is equaled or exceeded only once during the 50-year design life of an infrastructure. Here, that a specific year of exceedance can be any of the years through 50 years of the lifetime. That means we have 50 possible scenarios as follows. So the final answer is 50 times AEP times 1 minus AEP with the power of 49, which gives us 0.372 or 37.2%. We can then extend this problem to the case where we are interested in the probability that a flood with a given AEP is equal or exceeded k times during n years of design life. In this case, you can use the below formula to find the answer. Now let's solve another example using this formula. Imagine we want to find the probability that a flood with an AEP of 0.01 is equal or exceeded 5 times during the 40-year design life of a flood management infrastructure. Here, our AEP is 0.01, K is 5, and N is 40. So the solution will be like this. Let's go to the last example. The risk analyst of an infrastructure has advised that the acceptable risk of this asset is a 10% probability of experiencing one or more floods during its 7 years design life. The question is, what AEP should the asset be designed for? This is similar to our second example, but with a different objective. We said that the chance of experiencing a flood with a specific AEP within n-year lifetime is like this. Here, P is given 10% or 0.1, N is 70, and AEP is unknown. Inserting the given values into the equation, we will get this. And our final answer will be AEP equal to 1.5 times 10 power minus 3, or approximately 1 in 665. Understanding the concept of hydrologic frequency is essential for designing infrastructure, as our design decisions must balance risk, safety, and economic considerations. If you found this video helpful, please share it with others. Thanks for watching. I will see you in the next one.